Section 12.7 involves the surface area of a sphere. A sphere is simply a ball, okay? So it's a three-dimensional circle, if you will. Now, there's some definitions or some terminologies that we need to make sure that we have. The great circle is basically the circle that if I turned around and I cut this sphere in half, that circle divides this sphere into two hemispheres, okay, or two half a spheres. So this flat surface right here is what's called the great circle. It would be the space in the middle, or the circle in the middle, that separates those into two hemispheres, but the circle is the flat surface between those two. You can see somewhat down here in this picture, here's the sphere. If you cut it in half, you would have the great circle on this side, and you would have the great circle on that side. So it's the circle that divides a sphere in half. Okay, that's what's called the great circle. I encourage you to read through example 1 on page 672. I didn't want to draw the illustration here. You can do a much better job at looking at the illustration drawn in the book, making sure that you understand that you're doing Pythagorean theorem to solve that problem. So go ahead and read through example 1 on page 672. To find the total surface area, so that outside what would cover the sphere, so if you're talking like a basketball, maybe you're talking about the leather that goes around a basketball, or a softball, or any kind of ball that you're talking about, the surface area, not the space within it, but what would cover it. So let's say I wanted to find the area of this sphere given the fact that the area of the great circle is 201.1 inches. So you can see the great circle kind of drawn right here. Now, this is the formula for finding the area, the total surface area of a sphere. What we have to use this great circle for is to find the radius so that we can plug it back in. So you know the area of a circle is equal to pi r squared. So here's my area of the circle. This is the great circle. And so this would be this part right here. So what I'm seeking to find is the radius of that circle, which would also then be the radius of the sphere. I don't know that you can see that very well on there. Okay. So if I have an area of a circle is 201.1 inches, and it's equal to pi r squared. I'm going to solve for the r, so I'm going to divide both by pi. So I have 201.1 divided by pi. It's going to give me approximately 64, which is equal to the radius squared. So the radius is going to equal 8. Okay, so the radius of the great circle is 8, which is also the radius of the sphere. So total surface area of the sphere is 4 pi r squared. So 4 times pi times 8 squared. So that's going to give me 64 times 4 times pi is going to give me approximately 804.2 inches squared. So that would be the surface area of that sphere given this information about the great circle. Alright, so let's say they wanted you to find the surface area of a hemisphere. So that is basically half of your circle. So you have half of the total surface area of what a sphere would be, plus this area of this base right here. So if I was to come up with that formula, it would look like this. Okay, so if I'm talking about a hemisphere, which is a half of a sphere, okay, I've got 1/2 the surface area of a sphere, which is 4 pi r squared, plus that circle right there. So if you will, you've got this part plus that flat surface, and the area of a circle is pi r squared. So I've got a radius of 4.2. I just basically have to plug in. Okay. Notice that this and this are similar here. All right, so basically I have 2 pi, because half of 4 is 2, and then I have 4.2 squared. So this is going to be a 17.64. And so this is going to be a 17.64 pi. So if I figure these out, this part is 110.8. This part is going to be 55.4. When I add those two together, I am going to get the surface area of the sphere. So it's centimeters squared again. So remember, so your sphere is like taking your hemisphere is taking your sphere in half, but then understanding that there's a flat circle on top of this. So here's half of the total surface area for the sphere plus the circle that lies on top of it. Okay, hopefully you can see that. All right, find the surface area of the sphere given a great circle with this area. Okay, so we're going to have to use the area of the circle is equal to pi r squared. And so the area of the circle is 907.9 is equal to pi r squared. I've got to solve for the r. So 907.9 divided by pi is going to give me 288.99 is equal to r squared, or when I take the square root of that, it's going to give me, and it's going to round to 17. Okay, so now I've got the radius, which would be the radius of not only the great circle, but it would be the radius of the sphere. So I plug it into my formula to find the area of the sphere, which is that formula. So 4 times pi times 17 squared. And I get 3,631.7. These are centimeters, so centimeters squared. Okay. Then, if they ask me to find the surface area of a hemisphere with a radius of 3.8, if I want to draw this out, it kind of looks like this. Okay, so that's your half of your sphere. Okay, so I need to find half of the total sphere, and then I need to add back in the area of this circle. So remember, a hemisphere is half of the sphere. So the total area would be 4 pi r squared. I know the radius is 3.8. So 4 times pi times 3.8 squared is going to give me a total surface area of the sphere of 181.5. But I have a half of a sphere, so I'm going to divide that in 2. And that's going to give me a 90.7. So this is like the outside part of this, not including this circle. So now I got to find the area of the circle. So that's part of what I'm going to use as my answer. But the area of this circle, so remember circle is pi r squared. I better not do it that way. That kind of looks like circumference. Okay, so I have pi times 3.8 squared. And then I'm going to add this part that I already got right here. So 3.8 squared times pi is going to give me a 45.4. Now that's going to be this area right here. Okay, that flat surface. Then this rounded surface of my hemisphere was the 90.7, which is going to give me a total of 136.1 inches squared. Now that is the surface area of that hemisphere. Okay, now this one's a little different. This one says find the surface area of a ball with a circumference of 24 inches. So the distance around this great circle is 24 inches. Remember, circumference is equal to 2 times pi times r. So I have 24 is equal to 2 times pi times r. I want to solve for r so I can use it back in the formula to find the surface area. So I'm going to take the 24 and I'm going to divide it by 2 pi, and it's going to give me the r. So 24 divided by parenthesis 2 pi is going to tell me that the radius is approximately 3.8. Then I'm going to take that and use it in this formula, 4 pi r squared. So 4 times pi times 3.8 squared is going to give me approximately 181.5 inches squared, which would be the total surface area of that ball with a circumference of 24 inches. Okay, look at this for your homework, page 674 through 675, 10 through 15 all, and 17 through 24 all.